Alright, bet today we're going to be talking about the Nernst equation. And before we dive in, we need to review voltage. So voltage is basically just how much of a grip atoms have on its electrons. How much of a grip atoms have on its electrons, okay? So gold has a really strong grip on its electrons. Iron has a really weak grip on its electrons. Okay, so now let's dive in. So another topic we're talking about is why is salt water so much worse than pure water for corrosion, right? Salt water causes so much more corrosion than pure water. So as we know, we got electrons on the iron. The electrons got taken off by the O2 oxygen in the water, right? But whatever. We're talking about the salt water. So salt is NaCl, right? Na plus is the sodium, and Cl minus is a chloride. They come together, make an ion. So the Cl minus, it takes off this Fe2 plus atoms, right? These atoms that are on the surface that are dipped in the water, it rips them off. So there's no more protective layer there. And then the surface of the metal is going away and exposing the metal underneath, causing more and more corrosion. So now we know how the corrosion kind of happens with salt water. Okay, for pure water, there's no like major charges. There's no like really big negative charges to rip off the Fe2 plus. So not much corrosion, right? So now the equation, right? The equation we got, okay, let me explain this. So E is just the voltage. E with the degree sign is the standard voltage. Basically, how strong the atoms have a grip on its electrons in perfect conditions when it's not dipped in water. And then RT and F is gas constant temperature, moles, and Faraday's constant. That's just kind of like the adjuster. And then Q is dimensionless. Q is a ratio, basically the ion concentration in the water, right? So in here, there's so much more ions, right? You see all this shit going on? There's a lot of ions in the water, which makes it more salty. That's why it's salt water, saltiness. That's why I put saltiness. And basically, right, if Q is, so Q is how salty it is. If Q is salt water, so let's say it's 1000, this term is really big. And when you subtract a really big term, you get a negative result, right? So you get like a more negative voltage. But when Q is like really small, like 0.1 in pure water, then you don't really subtract much, and E is just like a average voltage, right? So why is basically a lower voltage worse, like for corrosion? Like why does lower voltage means like worse for corrosion? Lower voltage basically, it's um hold on, let me think for a second. Lower voltage, right? So the electrons come off easier in lower voltage. So now you got more Fe2 plus kind of like floating around in the water. These ions are kind of floating around in the water. And when they float around in the water, it combines with the oxygen in the water. So FeO, which means iron oxide. And iron oxide is basically rust. So that is why lower voltage causes more corrosion. Sorry, I needed a second to think there. So yeah, oh, last but not least, we have to talk about pH, right? Acidity. Why is more acidic water worse for corrosion? Because more acidic water has more H plus in it. And more H plus means you grab onto the electrons more and you take it apart more. So the iron is losing its electrons more when there's more H plus in the water when it's more acidic. And once again, the more easy it is to take off the electrons from the atoms, the less the voltage is, which means it's more likely to corrode. So I tried to explain it nicely today, but I think I did okay. So thank you for watching my video.